When we look at these two graphs from these two problems, does anything jump out at any of you that's maybe coincidental or interesting about these two problems when you look at them side by side? Anthony?
They both have positive slopes.
They both have what? They both have positive slopes? Yep, absolutely. Whitney? They're kind of like the same. Indeed, they are the same. Now, let's look at the information that's given to us in the problem. We have a slope of 2 and 0.0, negative 2. If we look at the equation as it is given to us, do we see those values represented anywhere in the equation? I'm seeing a yes from Anthony. Where do you see those values represented in the equation?
0 and negative 2.
So 0, negative 2 here comes from here in the equation. What about the slope of positive 2? Do we see that anywhere in the equation? Dwayne?
Oh, the 2 that is just a whole.
Yep, our coefficient of our x value is a 2. That is the slope of this line. So, what we've run in here is you've just discovered something about slope-intercept form. Why do you think it's called slope-intercept form? Dwayne?
Because they're like the same, or they're the same.
Looking at this equation, what does it appear is given to you based on what we just discovered? Anthony? Top. The equation. What does the equation appear that it gives us?
Slope.
The slope. Hence, slope. And intercept is a word that you don't really know. When we say intercept, we're talking about where it runs into an axis. So in this case, when it's in slope-intercept form, it's talking about the y-intercept. In other words, where it runs into the y-axis. And here it runs into the y-axis at negative 2. So here we have the slope and the y-intercept. And that's why we call it slope-intercept. So you've learned something about slope-intercept today, so let's learn by looking over at your aim and your key points for today. So starting with the aim. I did not leave myself enough space. I don't like you. I'm going to try again.
Oh, did I talk about me?
No. Fine. Okay. So our aim for today is that we will be able to graph an equation in slope-intercept form using slope and intercept. All right, so previously, how have we graphed slope-intercept form equations? Previously, how did we graph slope-intercept equations? You did this once today already. Geronimo. Yeah, we plugged and chugged. Somewhat time-consuming. But now that we know slope-intercept form gives us a point and gives us the slope, and we know how to graph with a slope and a point, we no longer will have to plug and chug if we're given it in slope-intercept form. The general equation for slope-intercept form is that y is equal to m, that's the slope, the coefficient of the x term, times x plus b. That's whatever number is being added on there. One thing you should notice about this, it says the operation must be a plus. If it's not a plus, what do we need to do with it? If we're not given an addition there, and we want an addition there, what do we need to do, Luis? Leave, change, switch. So, as an example of a slope-intercept form equation giving us a slope, I'm going to zoom in over here a little bit. Y equals 1/2 x plus 6. So what this is telling us is that 1/2 is the slope. And 6 is the y-intercept. Again, when we're talking about the y-intercept, we're talking about where the line crosses the y-axis. So if we know where it crosses the y-axis, that tells us one of the points on the line. Okay, so let's look at our first example. Sorry, I'm going to switch back to blue. And I'm not going to draw on it. All right. We seem to have some leftovers. Whatever. That's fine. Whatever, we'll figure it out. So, looking at this equation based on what we just learned, what is the slope of this line that is given to us? Based on what we just learned, what is the slope that is given to us by this equation, Grace? -4. So we're going to come down to our space down here. The coefficient of x was -4, and we're going to write our slope is -4. However, this doesn't have a rise and a run. How do I fix it so it's got rise and run? Anthony? Put a 1 underneath it, just like we did yesterday. What is the y-intercept of this equation? Cassandra? It is 3. It's what's added over here. So if the y-intercept is 3, what is the starting point? What is the point that is given to us? Dwayne? That is the slope. -4/1. That's our rise over our run. What is the point that is given to us if we know it intercepts the y-axis at 3? Anthony? 3 what? There's got to be 2 parts to...
And 0.
3 and 0, but which one's the 3 and which one's the 0? Perfect. So our y-intercept is 3, which tells us that our starting point is at 0, 3. Remember that any time we are on the y-axis, we have 0x. And that's what we're always talking about when we're talking about y-intercept in slope-intercept form. Yes, Monique?
Wait, so, I don't get how we got the 0.
So we got the 0 because we know this is the y-intercept, which means if it's going to be on this y-axis, that means it has to have an x of 0. Yes, Yura?
So, x, so 0 is x?
Mm-hmm. So we come and we're going to graph that point, 0, 3. Again, that's how we can recognize this intercept should always be on this y-axis, because it tells us where the line runs into the y-axis. Geronimo. For your y-intercept, it's always going to be on this axis, so it's always going to have an x of 0. Okay. We have a line. We've already written down the slope of this line. How am I going to move from this point to find the next point on the line? Esteban. Down 4 and right 1. Do it again. Down 4, right 1. Then take your straight edge. And draw your line. Yes, Cassandra. So remember we wrote down our slope earlier was rise over run, -4 over 1. Remember, so it's a -4 rise, that's why we went down 4. And then our run is 1, so that's why we went forward 1. Let's look at another example. Here we're given the equation y equals 2/3 x minus 2. This is almost slope-intercept form. What's slightly wrong with this equation that makes it not quite slope-intercept form? Not quite y equals mx plus b. Anthony?
Yes, exactly.
Has subtraction, so we should go ahead and leave change switch that. Y is 2/3 x plus -2. If we do not leave change switch that, we will end up starting in the wrong place. Sammy, what is the y-intercept of this equation? This equation that we have. It is -2. That comes straight from our plus b portion of our equation. So that means the starting point is going to be what coordinates? Sammy? 0, -2.
And for the rise and run, it's
Hold on, we're not there yet. We're going to go ahead and graph that point. And what is the slope of this equation, Sammy?
2/3.
2/3. It's given right here as the coefficient of our x. So we've got our point, we've got our slope. Rise 2, run 3, rise 2, run 3. Take your straight edge.
So we go up 2 and then 3 to the right.
Yep, so that's our rise and our run. Our rise is a +2, so that's why we go up 2. Our run is +3, that's why we go forward 3. And that's all it takes. That's all you have to do to draw the line. Give me a kip yes if you think this is much easier than the plug and chug method. Those of you who are saying no, that's totally fine. If you are happier with plug and chug, then you can move on with plug and chug. You get to choose from here forward which method you use. Let me ask you one more question. Give me a kip yes or kip no for this question. Can you use this same method, this same easy method, if the equation is in standard form? If you're showing me yes, you're wrong. If the equation is in standard form, it's not giving you slope and it's not giving you a y-intercept. If it was, then it would probably be renamed slope-intercept 2 form, because it would have slope and intercept. It's called standard form because it doesn't give you slope and intercept. Yes, Yura?
How would you know if it's time to move it?
That comes straight from our rise and run of our slope. Esteban. Esteban, what was your question? Yeah, so how do we know that -2 is the y in our parentheses? So that's because we know it is the y-intercept. So it's going to be the y. Dwayne. All right, so let's look over at the together time. I'm looking at the first equation on our together time, and there's something that's a little bit odd here. Adriel, what's a little bit odd here? Yeah, there's no y-intercept there. Is there something I can add to this equation without changing it? Adriel?
A 1.
A 1 changes it. If I tell you 2 plus 1, that makes it 3. But what can I add that doesn't change it? Selena? 0. So our y-intercept is? And our starting point is? 0, 0. That's the origin, which, by the way, I've added to our vocabulary list. One that I had not put up there that you need to know. I want to get you started on one more problem as well before you move on. I want to come over and look at the last equation. What's a little bit odd about this last equation? Brianna, what's a little bit odd about this last equation? It doesn't have a slope. There's no coefficient here. But we know when there's no coefficient, there's a hidden coefficient, which is a 1. Yes, Sammy?
What do we do when it's